So last section, just so you know, there's only 2 problems necessary for it. It's the law of signs ambiguous case, okay? So you're going to see what that means in just a moment. So in this case, you could possibly have 2 answers, or you can have 1. You just have to check. That's why it's ambiguous. So taking a picture of that, let's draw out our triangle. R, S, T. We have that the side T is 900 centimeters directly across from the vertex T. We have the side S is 690 directly across from vertex S. And we have that angle S is 56. We're going to find all possible values of angle T. So this time we are looking for an angle. So we're going to look for this angle T. And we're going to round it to the nearest tenth of a degree. So we're going to set up our proportions the same way. We already have our pairs matched up. We have this pair and we have this pair. So let's set it up. We know that for the S pair, the pair of S's, we have 690 centimeters over sine of 56. Sorry, that's a really ugly 5. 690 over sine of 56 is equal to 900 over sine T. And we don't know what T is yet. Okay, any questions about setting up our proportions? Okay, if you have a question, please interrupt me because I can never see if hands are raised or whatever. But we're gonna solve for sine T now, or we're gonna solve for sine T first. So in order to do that, I'm gonna remind you that you can use the butterfly method. So we're gonna multiply these two. So that gives us 690 sine T. We're gonna set that equal to those two. So the butterfly method, you just cross multiply. You can cross multiply because they are 2 fractions that are equal to each other. So then that is equal to 900 sine of 56. And then we're going to get sine T by itself by dividing by 690. And then that cancels those out. We get sine T is equal to 900 sine 56 degrees over 690. Okay, so we are not done yet. We're going to be typing in the calculator. So what can we type in the calculator is this. I'm writing it up here because that's where I have space. Sine inverse of 900 sine 56 over 690. This is what we're going to type in our calculator to get our T. So before I type it in the calculator, any questions? Come on, camera. I need my camera to work. Any questions? Okay. Maybe you don't have questions yet, but if you do, you need to interrupt me so that I know. I'm going to go type this in the calculator, and then we'll take it from there. Calculator, delete everything else. Okay, so sine inverse of, and then we just type this large fraction in there, 900 sine 56 divided by 690. Okay, and that gives us absolutely nothing. Well, that's weird. Okay, let me just double check my work to make sure I didn't mess up. Okay, so here's our work. Let's take a look. So RST, T is 900, good. Okay, S is 690, okay, and angle S is 56. we have 690 over sine of 56 is equal to 900 over sine t. Okay, 690 sine t is equal to 900 sine 56. Divide by 690, and we get sine of t is equal to 900 sine 56 over 690. Did I not type that right? Okay, I'm gonna assume that the fact that it gave us ... means that that's weird. Should that mean that there's nothing? Okay, I'm gonna admit that I am confused, so I'm gonna get this wrong and we're gonna look at the solution together. Okay. So the ... I guess means that there was no solution, which I know has happened before. When we have a ... it means no solution. I just didn't think that there wasn't gonna be a solution. So there you go, I learned something new today. Okay, so like I said, I was confused and we would look at the solution together. So let's just take a look. I mean, apparently we were right that there was no solution because of the ... I just didn't think they would have a question like that here. So yeah, they drew a picture and they labeled the sides. They set up the proportions the same way we did with the signs. And then yeah, sine of t is equal to 900 sine 56 over 690. You can see that right here. It's the same proportion we had. And then they typed it in and they got an error, which means no possible triangles. So I guess that was the solution. There were no possible triangles for this one. I didn't expect that, but there you go. So let's do another one that actually has, something that we can type in. Okay, triangle HIJ. So I'm going to draw you a triangle. HIJ. Side H is 9.2, so go directly across from the angle H, the vertex H, and we get 9.2 inches over here. Side J is 9 inches, so I'm going to go directly across from angle J, and we get 9 inches over here. And angle J is 19 degrees. So there, I've labeled those. Find all possible values of angle H to the nearest 10th degree. So angle H is this angle in question. So that's the one we're going to be looking for. And so let's set up our proportions. We have this pair right here, the 19 and the 9. So I'm going to put, I'll just write it here, 9 over sine 19 is equal to 9.2 over sine H. Any questions about setting up that proportion? Okay, let's do our butterfly method cross multiplication. So take those two, we get 9 sine H is equal to, cross multiply these two, 9.2 sine 19. Okay, and then we're going to solve for sine H. So I'm going to divide both sides by 9 so that those can cancel out. So we'll get sine H is equal to 9.2 sine 19 divided by 9. And so then we're going to type into the calculator sine inverse of that giant fraction, 9.2 sine 19 over 9. And this should give us the angle H. So before I type it into the calculator and hope that we actually get a solution, are there any questions? Okay, let's type this in. All right, so sine inverse of 9.2 sine 19. Oops. There. Divided by 9. Okay, so we get 19.438. We're going to round that to the nearest tenth of a degree. I'm going to screenshot this because remember this is the ambiguous case, and I told you you could have 1 or 2 solutions. Apparently you can have 0, 1, or 2 solutions. So here we at least have one solution, 19.438. Okay, I'm going to draw this on a unit circle. And you're like, oh no, the unit circle's back. I know. But you're going to be okay. Okay, so 19.438, I'm just going to round that to 19.4. Okay, so one of our answers is 19.4. That's for sure. I'm just going to draw that on the unit circle right over here. Not necessarily drawn to scale, but that's 19.4. And remember that right now we are dealing with sine values. So sine on the unit circle is the y value. So we need to think to ourselves, where else on the unit circle shares this y value? You just go measure its y value, it's right over here at this height. And then if you go continue onto the other side of the circle, you're like, oh yeah, there's another point on this unit circle that has a y value of 19.4, and that's on quadrant 2. So let's figure out what that angle is. So because we know that the unit circle is symmetrical, this 19.4 degrees that I just marked on the unit circle must be equal or congruent to that 19.4 degrees on that side of the unit circle. So if we know that this one is 180, and we were trying to find this giant black blob's spot angle over here that I can't point to, so I just put a star there, we're going to do 180 minus 19.4, because from the 180 part, we went backwards by 19.4. So 180 minus 19.4, and that gives us 160.6. So we have two potential spots on the unit circle where sine would become this weird fraction over here. So we're gonna test to see if those could possibly fit in the triangle. And so how do we test to see if they possibly fit in a triangle? I want you to remember that all the angles in a triangle add to 180 degrees. It adds up to 180 degrees. Hopefully that sounds familiar to you. And so that means if we have two known angles, we have this angle that they gave to us, and we have another one, either this one or this one. If we add it together, you cannot go over 180, because the moment you go over 180, that's not a possible triangle anymore, because all the angles in a triangle must add to 180 degrees. So we're going to make sure that when you add two angles, you don't go over 180. So we're going to try it out. Let's see if 19.4 can possibly fit in this triangle. So we do the 19 that they gave us, plus this angle that we are trying out, 19 plus 19.4. Let's see, is that less than 180? Yes. I mean, I don't actually know what it adds up to exactly, but wait, so 19 plus 19.4, that gives us 38.4. This is totally less than 180. So this works. This can be in a triangle, because when we added up only two of the angles, it was less than 180. So it's possible for a third angle to help it get to 180. Let's test out to see if this angle, the 160.6, if that can possibly work. So let's see. We're going to take the 19 that they gave us plus 160.6, and let's see, does that add up to less than 180? So 19 plus 160.6 gives us 179.6. Is that less than 180? Barely, but it is. So since this is also less than 180, this angle also works. So we are going to have two solutions because in both cases, we didn't go over 180, which means the third angle can help the triangle get to 180. Okay, are there any questions on this weird example? I know it's weird. We're going to have two solutions. The two answers are the 160.6 and the 19.4. Any questions?